In this video, we're going to look at how we could use what we know about parabolas to solve a problem. So the problem that we're worried about is when we've got a firework projected vertically into the air, we know that it's going to reach a maximum height of 100 meters, it's parabolic, and it's going to land 30 meters from our launch site. So often it's easiest to start by drawing a picture. So our parabola is 100 meters in the air, and we know that our parabola is going to be 30 meters across. The next thing we're going to do is we're going to determine some of our coordinates. Now, the easiest way to do this is to pick a vertex for our origin that is near the start of our equation. So if I put 0, 0 right where the firework was launched, it's going to keep all of our values positive. That's then going to make the vertex of our parabola 15, because that will be halfway across the distance of the entire firework, and then 100 meters high. So the first thing we're going to do is we're going to set up our function from our original general form of our equation. Y equals ax minus p squared plus q. Because we know our vertex is going to be 15 and 100, we know that the translation from 0 of our vertex is going to be 15. So we're going to have x minus 15 squared, and it went up 100. So we're going to have plus 100. The next thing we're going to need to do is figure out what a is going to be. Now, in order to figure out a, we're going to use any other point on our graph. And one of the points that we have that we could use is 0, 0. Our first 0 is going to be the x value. Our second 0 is going to be the y value. So I can substitute a 0 in for y, and I can substitute a 0 in for x. And then all I have to do is use some algebra to solve for a. So I can take 100 away from both sides, and I get negative 100 equals a over 0 minus 15 squared is minus 15 is 15 squared. I get 225, which means a is going to be negative 100 over 225. I could then reduce that fraction, and I could substitute it into my equation. So reducing that fraction, I'm going to get negative 4 ninths. So my new equation is y equals negative 4 ninths x minus 15 squared plus 100. Now that I have a new equation, I could use this equation to solve for my final question. How high is the firework traveling after a horizontal distance of 10 meters? Well, horizontal distance on this graph is going to be our x, and we're trying to calculate the vertical distance, or how high it is. So we can substitute in to our equation 10 for the value of x, and then just do some arithmetic to solve for y. So I've got 10 minus 15 is going to be 5. That's going to be squared, which is going to make this y equals negative 11.11 plus 100, which is 88.9 meters high. And if we look at our graph, that seems logical to us, because we know that to the center of the graph is 15. So 10 would be about right here in our graph. And if we extend up to our graph, we can see that 89 or 88.9 meters is a perfectly reasonable answer.